Lesson 5.2, Operations with Decimals, Part 2. This lesson is part of the Math 020 pre-algebra course taught at St. Louis Community College by Dr. Victoria Shearing. In the first part, we reviewed how to add and subtract decimals and also learned how to multiply by the powers of 10. And multiply decimals. So in the second part, we will be dividing decimals and dividing by the powers of 10. All right, so we are moving on to our last objective, how to divide decimals. There's two scenarios or two rules two cases that happens when we divide with decimals. The first is when we divide a decimal by a whole number. Okay, so when we divide a decimal by a whole number, we're going to write as long division, placing the decimal point in the quotient above the decimal point in the dividend. We're going to divide as usual. So you'll see what I mean about the decimal point, but just like it's very similar to when we added with decimal points. So we just do as we are. We divide using the long division, and when we come to the point to the place where we have to step over a decimal point, we're going to transfer that into the answer. All right. So we have 2.07 divided by 3. So we're going to set it up as long division. I have 2.07 divided by 3. All right, so the first question that I'm going to ask myself, does 3 go into 2? It does not, so I'm going to use a 0. This is different from when we divided with whole numbers because we never had to write the leading 0. We always had a whole number and we always had a whole number answer part. With decimals, sometimes we will have a whole number, but most of the times we will have the decimal 0 for the whole number. So now I'm going to look at the 20, okay? But as I'm looking at the 20, I have to step over a decimal point, so I'm going to transfer it up there, and that's all I need to do with this decimal point. So 3 goes into 20 3 times. So 3 times 6 is 18. So 6 times. 3 goes into 26 times. So that would be 18. You subtract 18 and you have 2, and you bring the next decimal down. 3 goes into 27 9 times. So 3 times 9 is 27. And when you subtract it, you got 0. So 2.07 divided by 3 is 0.69. So the second example that we're going to look at is 9.6 divided by 5. So let's go ahead and set up our long division. So you have 9.6 divided by 5. Okay, so in this case, 5 does go into 9 exactly one time. So we have 5 times 1 is 5. 9 subtracted 5 is a 4. Okay, and then we're going to bring the next decimal down. As I am looking at the next decimal, as I'm looking at the next number, next digit, I have to step over the decimal point, so I'm going to put it in the answer. Now I am looking at 46. 5 goes into 46 9 times, gives you 45. All right, so I still have 1 left over. 46 minus 45 is a 1. There is no remainder here. So since I don't have any more digits, I can always write the 0 in. So I can write as many trailing zeros as I need to. In our case, we only need to do it once because 5 does go into 10 2 times exactly. And now we do not have any more digits. When we subtracted our last partial product, we got a 0 as the answer. So 9.6 divided by 5 is going to be, the answer is 1.92. Okay. So that's the easy part. When we divide a decimal number by a whole number, all we have to do is transfer the decimal point in the answer as we use our lone division. Okay. So division by decimals, when you divide by a decimal, meaning that the second number is going to be a decimal, is a little bit different. Here we have a couple of easy examples first, and then we'll look at our problems and we'll formulate the rule. So when you have a dollar and you divide a dollar into quarters, you have 4 quarters. Okay. All right. When you divide a dollar into dimes, you have 10 dimes. You have 20 nickels. And when you divide a dollar by a nickel, notice that when you divide by a decimal, you started with a dollar, like with a 1, divided by 0.25, you got a 4. You divided by 0.10, you got a 10. You divided by 0.05, you got a 20. So the smaller the decimal, the larger the answer is going to be. And as a rule, when you divide by a decimal, you're going to get a bigger number as the result. Right? That is different from dividing by whole number with a decimal, because we had 207 divided by 3, we get 0.69, much smaller number. We had 9.6 divided by 5, we get 1.92. But the reverse happens when you try to divide by a decimal, you get a bigger number. So you start with a 1, you got a 4. You start with a 1, you got a 10. You start with a 1, you got a 20. Okay. So how does that happen? Well, we know the dollar is 100 cents. So if you divide 100 cents by 25 cents, that is your 4. 100 cents divided by 10 cents, you're going to have 10. And 100 cents divided by 5 cents, you get 20. So the difference between the first way that we did our problems and the second way is that we adjusted, we made the same units. So we no longer have a dollar divided by cents. We converted our dollar into the cents, and we got rid of the decimal point. So we're ready to formalize our rule. To divide decimal numbers, as always, you're going to determine the sign of the quotient, the sign of the result. Step number 2, make the divisor of a whole number. Divisor means the second number. Okay, so this is your divisor right here. Make it a whole number by moving the decimal point all the way to the right. So you're going to get rid of that decimal point. Okay, but you can't just arbitrarily get rid of the decimal point. If you're going to change one number, you need to do the same to the other one. Okay, move the decimal point and the dividend the same number of places to the right, writing zeros as needed. Once you convert your second decimal into the whole number and adjusted the first decimal or whole number, doesn't really matter. Once you get rid of the decimals in the second number, you can divide as if you were dividing just regular numbers, just like we did the first. So what we're trying to do is we're trying to get to something like example A or example B, where you're dividing by the whole number. So we're going to take our decimal, make it a whole number by moving the decimal point, and in the process, we're going to change both numbers. Okay, and then you divide, and as you, if you still have the decimal, you're just going to copy it down just like we did before. All right, so let's go ahead and do this with the first example. That's the best way to learn, is actually do the examples. So the first one, part A, you have negative 5.51 divided by negative 0.2. So negative divided by negative is going to be positive. So the first step is determine the sign of your answer. The answer is going to be positive. The second step is take a look at your 0.2. So you have 5.51 divided by 0.2. So I need to make this 0.2 a whole number. So I'm going to take the decimal point and I'm going to move it once. Okay, so that means I have to do the same right here. I have to move it once on the first number as well. I never change just one number. If you apply the same change to both numbers, you're going to be okay. Kind of like solving equations. What you do on the left side, you do on the right side, or what we did the fractions. If you change the denominator, you have to adjust the numerator as well. All right, so let's rewrite our numbers because I moved the decimal point once on both numbers. Now I have 55.1 divided by 2. All right, now my divisor is a whole number, which is the second number. The number I'm dividing by is whole number. I can go ahead and set up my long division. 55.1 divided by 2. 2 goes into 5 twice. Got your 4. 15. 2 goes into 15 7 times. So you got 14. Got 1. Stepping over the decimal point, so I'm going to copy it out in copy it in the answer. Bring the 1 down. 2 goes into 11 5 times. Need to fill in one more 0. And then 2 goes into 11 5 times. 27.55, and I've already determined that the answer is positive. So the final answer to this problem is 27.55. All right, so let's go ahead and look at part B. In part B, you have 3.2 divided by 0.02. All right, so I'm going to start with the both positive numbers, so I don't need to worry about the sign. Now I'm going to look at the second number. I need to make it a whole number by moving the decimal twice, 1, 2. So now I'm going to be divided by 2. So because I move the decimal point twice in the divisor, I have to do the same with the dividend twice. So I have 320. So now I'm actually looking at two whole numbers. All right, 320 divided by 2. 2 goes into 3 1 times. So, and then you have 12. 2 goes into 12 6 times. And then bring the 0, and 2 goes into 0 0 times. So the answer is 160. Do not forget your last 0. You can just automatically place it in the answer, or you can actually bring the 0 down and say, okay, 2 goes into 0 0 times. You have 160. Okay. So that's your answer for this one. All right. 52 divided by 9. So two whole numbers. You do not need to do any kind of prep work. Let's just go ahead and set it up as long division. 52 divided by 9. 9 does not go into 5. 9 does go into 52. Let's see, 5 times? No, that's going to be 45. Yes, 5 times. 5 times, that's going to be 45. We subtract, we have 7. All right, so we run out of the whole numbers, so we're going to put our decimal point in the answer, and now we can keep writing the trailing zeros until we actually get the division, get the final answer. All right, so now we're having 70. 9 goes into 76 times, 63. And then I have 7 left over, so I'm going another 70, so I know it's going to be 6. I am not going to be writing. I already see the pattern, so I can keep dividing and getting the 7 as a leftover. So it's going to be trailing sixes. So in order for me to show that the 6 repeats, I don't need to put the last one. I just need to put the dash above the 6. That means that digit repeats. Okay, so the answer 52 divided by 9 is 5.6, and 6 is being repeated right there. So part D, you have negative 12 divided by 16. The answer is going to be negative, and now I can set up the division problem. 12 divided by 60. So 60 does not go into 12, so it's going to be 0. And I'm out of digits already, so I'm going to put my decimal point, add my 0. 60 goes into 120 two times. You get 120, 0, and that negative 0.2. You're correct. Your final answer. All right. So here we are about to write another rule or make another important observation. So let's go ahead and do 3.1 divided by 0.1. So that means I have to move the decimal point once on both of them. So it is 31 divided by 1 equals 31. All right. So notice what happened. You start with 3.1, you got 31. So all you did is moved the decimal point once to the right, as many places as you had numbers below behind the decimal point. So let's do the 3.1 divided by 0.001. So I have to do it 3 times, and I have to do it 3 times. So I need to have 2 more zeros. So I have 3,100 divided by 1. It is 3,100. All right. So let's review this. I started at 3.1. I ended up at 3,100. So I divided by 0.001. So I had in total 3 digits after the decimal point. So I took my decimal point and moved it 3 times. 1, 2, 3. I had a couple of empty spots that I needed to fill, that I filled with 0. And that's how I came up with the 3,100. All right. All right, so let's switch gears. So this is the division by the powers of 0.1. And now we're going to do the powers of 10. All right, so this one, because we are dividing by a whole number, so we're actually going to do the long division. So I have 3.1 divided by 100. 100 doesn't go into 3. 100 doesn't go into 31. 100 does go into 310 3 times. So get 300, get another 0, so you have 131 minus 100. All right. So what just happened? When I divided by 100, notice what happened to your answer. Your answer is now 0.031. So you started with the decimal point between 3 and 1, and then you basically moved it twice to the left when you divided by 100. Now, there's 2 zeros, so that means your decimal point went 2 to the left. Okay. So let's do the last one, 3.1 divided by 10,000. We're going to do it. So I have 3.1, and then I have 10,000. All right. So it doesn't go into 3, obviously. It's not going to go into 31. It's not going to go in 310. It's not going to go in 3,100. And finally, it's going to go into 31,000 3 times. So I'm going to have 30,000. okay? And then 1 time into itself, minus 10,000. All right, so let's review. We started with 3.1. Our answer is 0.00031. So it is the same as taking, here's your 3.1, taking your decimal point and going to the left 4 places. 1, 2, 3, 4. This is your new decimal point. So you have 0, 0, 0, 0, 3, 1, exactly what we have here. All right, so here's our formal rule. Dividing by a power of 10, move decimal point to the left as many places, as many spaces as you have zeros behind 1. So if you have 100, that means 2, 1,000, that means 3, and so forth. Behind your 1. Okay. All right, so this is dividing by a power of 10. Dividing a number by a power of 0.1, so notice that we went the opposite way. So we are going to count how many digits we have behind the decimal point, and then we're going to move the decimal point that many digits. Okay, so move decimal point to the right. Move decimal point to the right. As many spaces as you have digits behind the decimal point. All right, so to divide a number by a power of 0.0, move decimal point to the right as many spaces as you have digits behind the decimal point. And then dividing by a power of 10, we're moving to the left. It's just a direction when we're moving. So, and then one last connection that we are going to make between these two is that, let's see, dividing a number by a power of 10 is the same as multiplying by a power of 0.1. So, dividing a number by a power of 10 is the same as multiplying by a power of 0.1, and the opposite. So again, and it's dividing a number by a power of 0.1 is the same as multiplying by a power of 10. We have 2 more problems in this section. Those are kind of review problems with order of operations. So let's go ahead and quickly tackle them on. All right, so we have in part A, we are going to do parentheses first. So then we're going to do the second parenthesis. That's going to be number 2. And then after that, we're going to divide. All right, so parentheses comes first. All right, so let's go ahead and do the first step. 1.5 minus 0.06. So 1.5 minus 0.06. So here we're lining up our decimal points. So we have to borrow. So you have 4, 4, and 1. 1.44. Okay. Step number 2. I'm going to add 0.12 and 0.24. So 0.12 plus 0.24, 6, 3.36. Okay. And then the third one, step number 3, I'm going to get the answer from step number 1, which is 1.44, and I'm going to divide by the answer from step number 2, which is 0.36. All right, so because my second number is a decimal, I'm dividing by a decimal, I need to get rid of the decimal point. So I'm going to move it, take the decimal point and move it twice to the right. Okay, that means I have to move it twice to the right here. So now what I have, my two new numbers are 144 divided by 36. All right, so let's go ahead and set up that 144 divided by 36. So 36 does not go into 14, and 36 does go into 144 3 times. No, 4 times. Yeah, 4 times. 6 times 4 is 24. 3 times 4 is 12, 144. All right. So step number 3 gave me 4 as an answer. So the final answer to this one is 4. Okay. So just make sure that these two problems are separated from each other. All right. And then the last part is we have part B. You have 35 times 0.2 plus 0.9 squared. Just a multiplication. All right, so let's do the 0.9 squared. So that's going to be first. I'm going to do this. Then I'm going to do multiplication. And then I'm going to add. All right, so step number 1. 0.9 squared. The number squared means the number multiplied by itself that many times, twice. 0.9 times 0.9. So that's going to give me 0.81. So that's the answer to step 1. Step 2, I need to multiply 35 by 0.2. So 35 times 0.2, 0.2. All right, so 5 times 2 is 10, 3 times 2 is 6, 7, and then I need to have, so it's the same as 35 times 2, which is 70. I need to make sure that wherever I place the decimal point, I have one number behind the decimal point. So the answer from step number 2 is a 7. All right, and then step number 3, I'm going to add them together. Still need that problem. All right, so I have 7 plus 0.81, 7.81. So here's 7. So you know what, let's do the other way. So because 0.81 is longer, has more digits. So you have 0.81 plus 7, 8, getting tired now, 8, 7.81. And that is your official answer to this problem, equals 7.81. This concludes our 5.2 lecture, part 2. Thank you for watching.